Good afternoon, ladies and gentlemen. My name is Mike Dory, and to my left over here is Bill Huxhold. And we'll be discussing torpedoes and the selection of submarines in conjunction with the environment. I have been working with submarines, RC submarines, for about 15 years. And in my particular boats, they all fire torpedoes. I work with gas, and Bill over here to my left.
Electronics, electric.
And together we hope to show you some interesting things. Let's look at what our torpedoes can do first. If you look at the slide over here, this particular slide that you see here on the screen was taken last July in New Jersey. And this is a Type 9 submarine. And we've just launched one of the 32nd scale torpedoes from it. These are gas-filled torpedoes, and they'll go about 40-45 feet. Here we see it motoring right along. They produce a volume of gas that is basically expanding 600 times when it hits the air. So it propels it sufficiently to go through the water at a reasonable clip. It'll be a little faster than scale. And here we have the Leahy, who happens to be coming in range. This particular shot also happens to be on video. If you happen to watch the SubPac videotape on construction of RC submarines, this actual shot is shown in that particular video. Okay, the torpedoes themselves are made out of solid aluminum. They are approximately 8 inches in length. The lower portion here is. It's 22 thousandths of an inch thick, or thereabouts. And we just simply we start off with a piece of solid stock aluminum, and we chuck it up in the lathe. And when we get done with it, we have a hollow tube about 22 thousandths of an inch thick. It's tapered the last 2 inches down to 1/8 of an inch. On the inside, we do the same thing, except the taper is kind of staggered as it goes towards the rear. Well, the rear portion back here, we get a drill bit for 1/20, I believe it's 1/27 thousandths of an inch, and we go ahead and just drill out the rear portion down here. Into that, we fit a piece of Teflon. This Teflon is about 3/8 to 1/2 of an inch in length, and it's 1/8 inch in diameter. And we simply leave the torpedo chucked up in the lathe, and take your tailpiece and very carefully press fit this Teflon into the rear aperture. We then go ahead and with the centering drill center up a hole in the rear portion of the Teflon, and we drill it out for 30 thousandths of an inch. This forms the aft portion of the torpedo. This is connected to the pin. And the pin in this particular case is a worn-out drill bit that we've simply rounded off the edges on. This happens to be for 35 thousandths of an inch. And this pin simply goes inside the Teflon about a little over 1/8 of an inch. It's just a pressure fit. At the forward end of the torpedo, we have nothing more than an aluminum block that is slightly oversized than the cylinder that is going into, and we have hot stuffed it in there. It's about 2 thousandths of an inch over. And we have forced it in there with CA glue, and to that we have attached a tire valve. We simply remove as much of the brass as possible while leaving the outside diameter the same. If you don't, you'll have gas escape around the outside when you go to fill this thing, and it'll smart on your hands. So going ahead and removing as much brass as possible, but leaving the outside diameter, we go ahead and fill it up with propel. And then here we have the buoyancy cap. This is the part that just keeps it afloat. It's about 2.5 inches in length, and it has a wood dowling that we have basically made round and placed in the end. That's all it is. Fits on there and it's just snug. And then this whole apparatus is fed into the torpedo tube, and all the servo does is pull the pin. The gas expanding at 600 times wants to get out of there in a real big hurry, and then you can see the result over here. And this can be done in several different sizes. Okay, this is a shot in this particular case, this was a shot at a lake using a 1/48th scale torpedo, which is a 1/2 inch in diameter. I happen to have one here. It's a 1/2 inch in diameter, and the difference between the two is the fill valve. This is too small to work with a tire valve unless you were going to make it a lot longer. It weighs too much and displaces too little. So what we have here is a 1/8 inch tubing. We have at this end a stop gap, just a little piece of brass that's been soldered on there to stop the piece from going all the way inside the torpedo. And then down in this portion we have 2 holes. And as you fill the torpedo, when it reaches its, you'll notice it's filled by the weight of the torpedo will change. When you feel that it has a little weight to it, pull the valve out. And when you do this, you move the holes past an O-ring that has been seated in here. So now you have both holes on the opposite side of the O-ring. When you go to load and you push it in, the holes are on the opposite side of the O-ring and it fills easily. In both of these cases, accuracy of the torpedo is maintained by basically having the torpedo spiral while in motion. You take the fins, and they're nothing more than about 80 thousandths thick plastic, and you simply take the rear portion of them, about the last 1/8 of an inch or so, and cant them off to one side. So the torpedo rotates in the water at rather a high rate of speed, much like a bullet going through a barrel. And with the constant rotation, any little being a little bit off center with your drilling, or in this case, when I pass this around, you get a chance to see it. This is right on one way, but it's not right on another. It's off a few thousandths. But you'll notice that it goes straight in the photographs, and they do pretty well at the lakeside, and that's how accuracy is maintained, by just simply having the torpedo rotate through the water. Okay, a word about the gas that we're using. We've been using Propel. Propel is a propellant that is formulated by 1 part butane to 1 part dialfulminate, something or other here I can't pronounce. But at any rate, it has no CFCs. There's nothing that would be hazardous to the environment with it. The pressure in this particular propellant is 50 pounds per square inch at 70 degrees. Of course, if you leave this can out in the sun a little bit, why, it goes up with the warmth of the weather. But it's a very low pressure situation. These torpedoes will go about 40 feet. Now, Bill over here uses electric, and I tell you, I am very envious of his engineering skills. He's a Crafts A #1 machinist, and I wish that I had not only his workshop, but his skill to go with it. And I'll let Bill go ahead and take it from here.
Well, I'm basically working on a different principle, and that's electric torpedoes. Which really means that I have a set of batteries and an electric motor in the torpedo going through a gearbox driving 2 propellers counter-rotating, which is, as Mike said a little while ago, quite an engineering piece even to come up with the gearbox. The gearbox is very tiny. I can go and build gearboxes to go into watches without any problems. But the problem is getting electric motors small enough to go into torpedoes. The smallest I have achieved now is 1/33, and that is still fairly large. Now this is a 1/33 type torpedo. They're fairly large. They're 5/8 in diameter by about 8 inches long. Now I have a line on some tiny motors. The motors are about 3/16 diameter by about half an inch long, but I have problems getting them. They come from Switzerland. But anyhow, to go back to this type of torpedoes, as I said, I have the front of the torpedo contains a set of batteries. I have on the battery holder, I have a reed switch which is normally closed. but that means the contacts are normally closed. So, okay, that's fine. That drives the motor, and the motor in turn drives the gearbox. I don't have a gearbox here, but the gearbox is built in here. But anyhow, in the nose cone, I have a built-in switch, which is contacted by the pin. By pulling out the pin, the torpedo runs. Okay, I hit something, and it shuts off the torpedo. The way I have designed this thing is, when I load the torpedo into the tube, I have a magnet on the outside of the tube which shuts off the torpedo. Now, once I fire the torpedo out of the tube and the torpedo leaves the magnetic field, the contact will close and the torpedo starts running till I hit something, and it shuts off and the torpedo goes down to the bottom. So therefore, it's not really, this type of torpedo is not really something you want to lose too often. They're a little bit on the expensive side. Like when I buy those motors, I'm looking at about $50 a motor. And that's something I don't want to lose too often. Counter rotation is achieved by 7 gears in the gearbox, and that includes the motor pinion. So that's 8 gears, pardon me. It's 7 gears in the gearbox plus 1 which sits on the motor. The pitch of this is very, very tiny, very fine. It's about 120 diametral pitch, which is very tiny. 120, 170, I think. But anyhow, I have different tooling here. All of my stuff, like the nose cone and the tail section, is made out of solid aluminum. I have the tools here to hollow out the inside, and there's a little pip on the inside which takes the switch, the shut-off switch, okay? This outside tool here is to form the outside, and once I have this cut up, the other side of the tool is more or less for finishing. This is an arbor where this nose cone screws into, also the tail section screws into, to finish the outside, okay? The inside is done by drilling progressively, and the finishing is done with a D-bit. Now, all of those things, they do have O-rings, O-ring seals on there. Like the pin has a wee tiny O-ring up front. The nose cone has an O-ring. The tail section has an O-ring. So when I screw everything together, everything is tight, and mind you, they don't float. But the real ones didn't float either. You know, you shut them off and they sunk down on the bottom, okay? But the black things you see on the side here, those are simply battery containers. In other words, when the battery is exhausted, I take the battery out, I put them in here, I put them on a charger, I recharge them, I put them back in here, and I'm off running again. Those torpedoes will run about an hour.
What
So
voltage do they run at, Bill?
Pardon?
What voltage are they running at?
Well, they're NiCad batteries. Each one is 1.2. I'm running on 3.6 volts. The motor is actually only about 2.8 volts, but I'm running about 50% over, which gives me the extra RPM and the extra ump I need in order to get moving, okay? The power with those motors is very tiny. The slightest friction going to the gearboxes and whatnot reduces RPM. RPM reduces the speed of the torpedo. I won't be able to keep up with speed because I don't have the speed, okay? I don't have the pressure. But we run them this morning, and I think they run quite nicely.
I agree.
I hand this board around for people to go and take a peek at. Are there any questions pertaining to? Yes.
I missed the beginning, but how did you maintain water integrity with your little button in the front to keep the water out of the nose?
I have an O-ring
For the little
sealing off. Oh yeah, a wee tiny O-ring sealing off the wee tiny pin in the nose cone. I think if the thing goes around, you will see how this is achieved by the half section of the nose cone.
also very interested in how you got the counter. You said you had a gearbox for a counter rotating. You must have a shaft that goes inside of the shaft.
Yeah, what I use for counter rotation is hypodermic needle with a solid shaft on the inside. What I use an 18 gauge hypodermic needle, which is 50 thou outside and a 30-second inside. Okay, and I use the 30-second solid piece of stainless steel as the inner shaft. Okay. The gearbox itself is brass turning. It's turned down about 1.5 inches down to about 80 thou to give me the stuffing box. Okay, and the front portion is actually the gearbox. It's 3/8 by about a 1/4 inch long.
Do you have one of those at the pound to look at too, or really?
This is one of the drive units. I have in the torpedoes. It's the motor. It's the combination of the motor, the gearbox, and the inner outer shaft, plus 2 propellers. And if you rotate one propeller, you will find that the other one counter rotates through it.
Is this a planetary gearbox type of thing, or just a couple of gears?
There's straight gears in there. I do make my own gears. The gears, unfortunately, happen to be 0.2 module, which is a metric type, and that actually comes with the motor. Okay, like the pinion on the motor is not removable; they're welded onto the shaft. So I have to go by what they have. But I should go back a little bit further. I have complete machine shop facilities, including a gear harbor. I used to make gears for a living. So making gears is absolutely no problem. Making the tiniest gears is no problem, okay? So I have a little bit of an advantage there. But when I saw Mike Dory this morning, I think I'm going to scrap mine because they're too expensive, and I think I'm going to go and give them a competition.
Okay, this is my backyard, commonly known as a test tank, and here's another 1/48th torpedo. Matter of fact, this one happens to be the exact one that we're passing around right now. This is coming out of a Gato class boat. This is kind of a unique shot. This is an underwater shot, and one of the problems that we have with RC submarines is when you fire a torpedo from underwater and they float, you have to have some way of getting rid of the gas. So here we have you can see when it was fired out of the tube, you can see the bubbles coming up from the foredeck of the submarine. This is a way of getting rid of the bubbles out of the tube before you broach, because they'll just basically pick up your whole bow, which is not neat. So we have, at the top of the torpedo, we have various holes up there to get the air to dissipate quickly through the torpedo and up through the top of the deck. Next shot. This is much the same thing, except it's on the surface. Next. This is a Type 7. This was the boat that we had doing most of the shooting on this particular occasion. It's nothing more than a 30 seconds parallel hull kit. This happens to be a model of the U-230. Okay, they'll give you an example of some of the power of some of these things. That's about 25 feet already, and you can see the wake in the water, and she's still coming right along. Okay, that's another shot. This is just a little later. They have, the pressure can vary, and so the range will vary. If you load up your torpedoes and you have your boat on the shore side, for instance, and you're waiting your turn to run in the water and it's a warm day, you may have some problems. And what I've experienced is that as soon as the pressure inside the torpedo expands to the point that it overcomes the friction of the pin, they simply cook off all by themselves. And they'll fly through the air about 20-some feet or so. And I have been known to be retrieving these things out of people's picnic lunches and everything else. I was going to tease Dave Merriman. A year ago, we were down here, and the Navy, when they heard we were going to fire torpedoes, they got really excited. So they made us do it, load up the torpedoes and everything from a special table. And this table was out in the sunshine. So we're over there loading these things up and everything else, and one of these things cooks off. I couldn't get in the water quick enough. The guys were still on the course. One of these things cooks off, and it goes flying across the grass, and this rather middle-aged, pleasantly plump individual of the female variety was standing there at the fence line, and her legs were slightly spread as she was hanging on to her 5-year-old son, or it looked like about that. And this torpedo goes right between her legs, and Dave Marion walks up there like there's nothing wrong at all, reaches down underneath her legs and pulls out this torpedo and goes walking away. And I thought, Dave, you were the bravest man around. But the best recommendation is, once you load them up, put the boat in the water. The water is cool, and it will stay, it'll keep them from becoming increased pressure, etc. And you won't be out there trying to retrieve them from between somebody's legs or thereabouts. Next shot. Much the same thing. The problem is that when they come out, they're just barely buoyant with the fluid in them. Well, as the torpedo uses up the fluid, they become more and more buoyant. And one of the good things about these kinds of torpedoes is that you can get them back. They float, and we were firing them at shoreline today, and the boat was going out there picking them up. Last year, I had the diver swim out there in the course and retrieve them. They're made to float. It's important, at least it's important to me, that I get them back. They're not near as expensive as my friend Bilge over here, but they do take me about probably 3 or 4 nights, an hour or so a night before I can complete one, and I would just as soon keep it. I had an experience with missiles. How many guys are familiar with Estes rockets? I had this Polaris boat in 1/48 scale. It was really a kind of a nice boat. Matter of fact, today it sits inside of a hobby shop. And I had cut down an Estes Alpha rocket, which has a plastic nose cone, and I'd cut it down to fit inside the tube. And I got the boat down about 6 feet underwater. Matter of fact, it was on the bottom of the pool, and launched it. And it really worked well. Those Estes rockets will burn underwater great. Well, it came out of the water, and not unlike the real ones, to a point when it broke the surface tension, it angled off a little bit to the side, about 45 degrees. And it went ripping right on up, and it looked really neat until it hit the overhang, my patio overhang over the pool. When it hit the awning of the pool, it ricocheted off that, went inside through my neighbor's window, okay? And my neighbor is 70-some years old, and this rocket is now burning around on her carpet, going around like this, you know? And then to make matters worse, just as she bends over after this thing is done bending around, the ejection charge goes off, okay? And if that wasn't bad enough, my particular profession, I work fatal accident investigation. I'm a deputy sheriff. And it's very difficult to go over to your neighbor and say, gee, may I have my rocket back, please? I have since given up anything to do with Estes rockets. But it was a nice try. I also played to have her carpet cleaned and the new window, and was very humble about the whole thing. Besides all that, your kids, if you have any, I will tell you, will never let you live it down. I also got the cameraman in Vancouver. We were at a subcommittee seminar up there, and it was about the length of this room when we fired this torpedo. And this cameraman is sitting there, you know, from the news station. He's recording this whole thing, and this torpedo comes right out there. It goes right up the shoreline. It goes right between his legs, and stopped. And the last thing he says is, "Look at that! Damn!" And it was on the news that night the same way, too. As a matter of fact, if you buy the tape, the SubPac seminar tape for '92 in Vancouver, which is where this shirt came from, you will see this particular shot also on the tape. It's an interesting shot. Okay, well, if there are no further questions on torpedoes, the other thing that we're supposed to talk about for just a few minutes is something about choosing a boat and some considerations that you might give some thought to. Of course, everyone thinks of cost, and that obviously has a big deal or a big thing to do about it, but construction techniques and the types of boats that you pick for particular areas are really important. When you start talking about submarines, everyone looks at the pond and says, gee, this is a nice place to run, and they are looking at the surface. You need to know what's under the water. Do you have a sandy bottom? Do you have a muddy bottom? You can get in some of these places and go out here and find out that that bottom has such a suction to it, you can get stuck in the mud and never get up, regardless of what you have. So it's really important to know something about the environment that you're in. Do they have, sunken trees, or did you have a lot of flood this last year, or something like that, where you have an abnormal amount of brush or whatever in the water? Those are things that really hang up model submarines real quick. Another way that guys lose submarines really neat in pools of water is run into about 20 foot of monofilament line and a 4-ounce sinker. That's all it takes, and you're on your way to the bottom. So you really got to know not only what's on the water or what's in it, but what's along the bottom. Also how deep it is. Makes a big difference on your construction techniques. You buy one of these lightweight boats, a Type 23 from 32nd Parallel is an example that I could use, or several others. If it's a lightweight construction boat, that means you're going to have to keep your construction techniques light as well. And lightweight construction is limited to very shallow dives. Now, I run in two environments. First of all, San Diego County supplies a saltwater basin, and I'm probably one of the fewer guys that run in salt water. You have to take special considerations there. Nothing that is exposed, of course, that's metal can be in salt water without rusting. So you end up covering everything with either resin or RTV or some other type of covering if you want to keep it. Disseminal metals become a problem. You want to stay away from that as much as possible. Those are considerations in salt water more than any place else. In freshwater, the depth becomes the consideration. One of the lakes that we run in, that I particularly run in, the shallow end is 25 feet deep. Now, if you're going to build a boat that could conceivably sit on the bottom 25 feet down, you're going to have to use some techniques that are a bit more robust than some of these smaller boats can take. On my particular boats, I use a bolt and nut to hold down the pressure lid, and I have that bolt every inch. I have a very thick Lexan. Stick with Lexan. Stay away from plexiglass. Plexiglass will crack on you if it's under any kind of pressure. Any kind of change in temperature, like you're using it in a ballast tank situation, it'll graze on you and crack. You want to stay clear away from plexiglass. Use only Lexan. Lexan will take the pressure. Lexan will take the... Matter of fact, if you get Lexan thick enough, it's even bulletproof. That's true. It is what you want. It is more expensive, unfortunately. A lot of guys are losing a lot of their ballast tanks because of plexiglass. If you want something that's inexpensive that appears to be working pretty well for ballast tanks, I would try water pipe that you get for your landscaping. Schedule 40 ABS pipe for landscaping works really well. It's rated for 90 pounds pressure. That's your pressure that you get from water pressure coming off the street, and it'll handle it. Matter of fact, Skip AC is selling propel tank containers that are made of the same material, and they've worked fine for years. It's less expensive than Lexan, and it works great. If you're looking at a type of boat, you should have a special interest in the type of boat that you pick. If you don't, you won't get it done. You really have to have a love of your boat. It's basically that's what we're involved in. It's a no one could pay you to make this boat. You have to have a special interest in this particular boat. Some boats make out better than others. For instance, World War II fleet boats do not have on them guards around the diving planes. So they are very prone to pick up monofilament line. They're very prone to pick up grass in the props, twigs, anything that happens to be in the environment. Conversely, your German boats all have guards around the props themselves and around the diving planes. They are less prone to pick up these sort of items in the water, so they have a better survivable rate. Nuke boats. If you're sailing in an area where you're having to share the water with a lot of other people, and I'll tell you right now, the worst of the bunch, God bless them, is these old-timers. They get out there with some old-time radio that they made back in 1948. They're still using test tubes, okay? I mean, really, some really vacuum tubes in these things, and they swear by them. They made them, and that's it. But they go out of control a lot, too. The range is very limited with them, and most of the time they're not watching their boats anyway. They're drinking coffee and talking to their friends, and they're not going to see you running around at periscope depth. Now, if they're running one of these sailboats, they have a keel that's 12 inches down with a lead bar hanging off the bottom of it. It's going to take you out. World War II boats do not survive well in that environment. However, the nuke boats, purely because of their shape, do very well. For the most part, unless they get hit right at the sail, if they're just fore or after the sail, that keel is going to do nothing but push that boat down a little bit. Oh yeah, you're going to have to touch up the paint job, but that's all. It just pushes you down and it comes back up. You do the same thing on a World War II boat, and those keels get entangled in the railings and in the guns, on the conning tower and on the deck there, and they hang on to you and they just drag you everywhere. And when you get it back, it looks like a piece of trash. So I look at these environmental things all the time. We have to work with a bunch of float planes. You want to talk about some sharing the area, this is really neat. You get these guys coming in with their float planes and they can't see you at all. About the time you surface, here comes this float plane coming right at you. You can have some interesting things, but the big thing is to know the area that you're sailing in, what you want to do with your boat. Also know the limitations of the state or the territory, or the province in Bill's case, of where you're at. A lot of states won't let you use Freon. Connecticut, right here, will not let you use Freon. Forget it, it's gone. Some states will. We're using, again, Propel to blow the ballast tanks. Or some of the guys are using CO2, compressed gas. A lot of the guys are using pumps. If you have a pump boat, most of the pump boats, for instance, the Ingle system and the Darnell system, both are using a motor that is through a pump to take on and discharge water. That's all well and good, but they draw a little extra current because you're having to run these all the time. So you have to have a battery capacity on board that can handle all of these motors. I had a Type 9 that had 4 Ingle pumps in them. Each pump draws 5 amps. So when all 4 of them are on together, you're drawing 20 amps. Now this is a lot of current. So if you're going to go with a boat like that, that's fine, but just remember your battery capacity has to be large enough to handle it. You can't get out there and draw 20 amps with an 8 amp battery and expect it to last long. My best recommendation before you ever get a boat or even think about a boat is find an area where you want to run. Go and talk to other people who run at the lake. See who's there. Is there a bunch of gas boaters there that go? Do you have to share the area with gas boaters? These guys go at 60 miles an hour. They're not going to see you. My best recommendation is if there's gas boaters in the pond, take your boat out. They will not see you, and they will destroy your boat. If you're running with a group that is scale operation, that's great. That's where you belong. But also be careful of what's in the water, how deep it is, what techniques you have used. For instance, one of the things that my partner, Skip Acey, uses is he uses a little RTV or rubber cement around his hatch for his watertight box. He just goes ahead and smears it around a little bit, puts it down. Real thin bead, about 1/8 of an inch or so. This works really well in the environment that he runs in. This would not work really well if you're using an Ingo pump system. Ingo pumps, when the pump, basically an Ingo pump, for those of you who haven't heard of them, is it's a giant piston. Well, better yet, it's a giant syringe. It simply is sucking the water in and blowing the water out. Well, when you suck that water in, what have you done to the air pressure inside of your box? There is more air pressure in the box trying to get out than there ever will be water pressure trying to get in. If you have used the rubber cement to seal down your hatch covers, it isn't going to work. It'll blow that thing right off in time. It takes a little time, but it will find a weakness and it will blow it off. If you have pressure the other way, it seals fine. If you have greater water pressure on the outside than you have air pressure inside the box, it seals great. Skip right now is selling seals over at the lake, a seal kit. These are meant for anything but the Ingo pump system, because the seals, again, seal in one direction only. So it's important that you have some idea of where you're going to run, who you're going to run with, what do you have to transport this thing. It's really neat to go out here and get a 32nd parallel Gato class submarine that's 10 foot long. It is not so neat when you have to ask your wife every time you turn around to pick this thing up and move it. My Type 9 is 78 pounds dry. It's about 150 when it's wet. And it takes 2 people to pick this thing up and put it up out of the water every time. Now, my blushing bride is very tolerant, but she has told me that enough is enough. We are looking for something smaller. And basically, that's one of the big reasons for it. This thing's a heavy thing to be moving around. You mount all your batteries in there and everything else, even when it's dry. You're going to do a little work. Let's say that you want to do a little patchwork on the bottom or something like this. Just to move this thing is 2 people all the time. So you got to think about some of these things before you just walk off and say, hey, that looks really neat. Let's go ahead and get it. I would tend to stay, if this is your first boat that you're considering getting, I would tend to stay with a medium-sized boat, nothing that's too awfully small. You don't want anything that you have to get involved with real miniaturization on your first attempt, and nothing too awfully big and cumbersome that you have to move around. Stay with a medium-sized boat and pick one that best describes the environment that you're going to have to run in it. Are you going to have to use pumps? What pumps are available? How big are the pumps? SureFlow makes a pretty fair pump. It's a reversible pump, and it lasts a fairly good length of time in fresh water. I'll tell you, in salt water, they don't last a week. But in fresh water, they last a considerable length of time. What's another good pump that I can think of? I went down and got bilge pumps. I went down to the marine store, and they had bilge pumps for these 16-foot outboard runabouts. So I pitched up a small bilge pump from those guys. I was running one of those for a long time. Worked pretty good. They'll move a lot of water quick, and they're made to run in salt water. So it worked out pretty fair. If you guys that are running pump boats, all boats need a fail-safe system, a missing pulse detector of some kind. Tom Yergi from High Tech is selling them. I provided Tom with the schematic that he's currently using. It's a pretty good one, I think. I've had it running in my boats for over 10 years. But I will tell you that they were developed primarily because I lost a boat and it went to 33 feet and stayed there for 3 days. You've heard the expression that necessity is the mother of invention. Well, losing this boat was worse than losing the kids. Trust me. And going home with an empty boat stand is not what you want to do. All boats, all submarines, when you're testing them and everything else, are going to sink. The question is, which one's going to come back up? And that's the bottom line. So whatever you're looking at, be sure you pick up a missing pulse detector, either to one of Tom's, or if you get a handout from one of the sub-seminars that we've done, there's a couple of schematics in there of different types, and you can build your own. If you have a pump boat, you can hook up that situation to a couple of weights, just charge the weights and bring the boat back up. I had a Type 7 U-boat that I ran around for years that way. They got in trouble, and it did often. I had to release 2 4-ounce sinkers, one in the foredeck and one in the aft deck. And no problem, she'll come right back up. And it was a whole lot easier to go get these fishing weights that were 4 ounces. They were kind of flat, and I just made a little well in the boat and just cut out the bottom of the boat, so it was being held in there by a pin. And when the fail-safe operated, it simply withdrew the pin from the hook on the top of the lead weight and just simply fell through the keel. But you do need to have something. Don't ever make a boat without them.
So you probably prefer sink weight and just full ballast?
Blowing ballast works fine, but the pumps boats they have to have an air source. So if you're sitting there and you're trying to operate this pump underwater, all you're doing is exchanging the water. You're not getting any lighter by doing it.
Also, maybe the pump boat may run out of juice and the battery completely goes dead.
So that the releasing the weight has an advantage. A lot of the guys end up making they get these little fishing bobbers, and they paint them up like rescue buoys, and they put them out there on the boat, so they just simply pull a pin there and this buoy comes up. And I said, well, that's really neat, guys, but that doesn't get back your boat. All that does is tell where the boat is.
Hopefully the line is strong enough to pull it forward.
That's true. So I would rather get the boat back. Seems reasonable to me.
Interrupt there for a second. I'm building a Type 2 right now, and the Type 2 has a telephone buoy built in. The way I'm going to do this is I'm going to have a solenoid inside the boat. Anything happens, I have a time delay in there, after 5 minutes or 10 minutes, whatever the case may be. The buoy comes up, attached to a heavy string. If something happens, I just go and pull the string up, and my boat comes up.
So that's Bill's
It's
answer.
another method of doing things, okay?
But you do need to think of some way of getting the boat up in emergency, because not unlike the real ones, they have very little buoyancy, and you get them down below a few feet and they will settle on the bottom. And you've got to have some way of lightening your boat. If you don't, you're in trouble. Some of the boats, I figure in my Type 9 I probably have, well, it took me 3 years to build it, and I probably have a couple $1,000s in it. I would really cry a lot if I lost this boat. So if you're going to invest this kind of effort, time, and money, don't forget to put one of these things in. And check the area that you're running at. Also the people that you run with. It's so important. You can't believe how important it really is. You can have a real nice boat out there, be running around by yourself, and some other yo-yo's over here, and all of a sudden he shows up at the pond. He doesn't bother to come down and check his frequency flags or anything else, and he gets out there with a power boat. and you can find yourself in real trouble quick. Also, it's really good if you're going to build one of these things to get a buddy who is also building them, because each of you will encourage the other one. And I will tell you that there will be times, we call it challenging. My wife called it depressing. There were times that you're out there just swearing at this thing. Why isn't this working? It's supposed to work, and everything else. And you're going through the schematics and everything else, trying to find out what's wrong, and you're just, nothing but gross frustration. My wife got me this little sign. It says, "Are we having fun yet?" And she put it over the workshop. And you have days like that. But it's important, if you have a friend that's building them at the same time, that you can sit there and you kind of brainstorm it off of each other. And sometimes you'll hear the old expression, you can't see the forest for the trees. Well, it happens a lot in this kind of building. So if you have a buddy that you can get back and forth with, and he can see things that maybe you're not looking at, or maybe he has an expertise in a particular area, and you kind of go back and forth with each other, it really helps out a lot. So I highly recommend it. This is not a project that you start today and you're going to end it tomorrow. This is one that you're going to have spread out over an area for a period of time. Like I said, I think it took me about a total time about 3 years. That means my wife and family put up with a messy garage for 3 years. It just takes some time. This is not something that you start around the house when you have a bunch of toddlers. So consider where you're at, what you have, where do you have to run. Consider the state laws where you're at, what kind of a system you want to build, etc. And make a decision on a boat hull that you want based upon, amongst other things, where you're going to run the boat. Well, there's several different types of fail-safe systems. One of the type that's on the market is that basically works on a pressure system. You go below about 2 meters or so, and this basically the pressure engages a switch, and it blows your tanks, and you come up. The problem with that is you can lose your boat in very muddy water at 5 feet, and it's going to be there forevermore. It doesn't get your boat back.
What about the radio frequency with penetrated water?
No problem.
No problem?
How far a radio frequency will penetrate water is directly dependent upon the mineral content of the water that you're in. You guys out here on the East Coast are very lucky. You have some very nice, clear water. Where I'm from in San Diego, everyone has saltwater conditioners because the water tastes like rocks. The mineral content is very high. So how far I can go down out there, I have been down about 6, 7 feet. Out here, I've had the boats down 25, 35 feet. Pool water is also contaminated. We run in pool water occasionally in Olympic-sized swimming pools, things like that. And if they have changed out the water over the winter and it's fresh water, you'll be able to sit at the bottom at 12 feet, no problem. But if they have not, if they've kept it, like last year we had a big drought in San Diego, and if you had water in your pool, you kept it. I was lucky if by the end of the season I was able to get 6 inches underwater. Just straight mineral content will have a detrimental effect. An example, when I run in salt water, I have to have the antenna out of the water about 2 inches. I run it right up inside the periscope. But if I run in fresh water, I have been down 7, 8 feet, no problem. In pool water, I have been down 12 foot one year, and the next year only be down 6 inches before you lose contact. Nothing wrong with the radio. It's what's in the water. And you can't see it. There's no way to look at this water and say, what has it got in it and how far should I be able to get down? You have to try it. Out here in the East Coast, you guys are very fortunate. You have a lot of rain, and you get a lot of fresh water that's very clear. In the West Coast, in Southern California, we don't get a whole lot of rain, and unfortunately, the water that we get is full of mineral content, very high. Traveling with boats is interesting. I have a motorhome. Well, my wife sometimes thinks so. She thought we bought it for her. I'm going to get killed if she sees this tape. We put the boats, basically, it's a motorhome, and we put the boats on a double bed, and we just put a a blanket. No, we have the one over the cab, and we sleep up there. But you know, that's how I do it. The boat that I think is really neat is a Type 2 U-boat, and the reason for that is it is very small. It's small enough that I can put it in the overhead compartment of a 757. I already checked. We have done this. It'll fit. Anything that'll fit in the overhead compartment is what you have to do. And I'll be honest with you, 737s and 727s it won't make, but the 757s it will. So if you call the airline and say, hey, you know, what have you got going and what size flight it is, if you ask for special loading, they'll bring you on the aircraft first. And then you just put it in the overhead compartment, and that's it. Then anybody that comes in after you, they got to share. It's neat. It works. And Skip's flown back and forth between the West Coast and the East Coast a dozen times with his. He's got, well, his stand is part of his case. The top part just basically goes over the bottom section, the base, and it just simply screws on. He picks it up by a handle and walks off. The other thing about that particular boat is it has fore and aft diving planes. Boats that only run on a single set of diving planes are a little more difficult to run. They're a little faster usually, like the nuke boats. The forward diving planes on a nuke boat are just about useless. That's because they're too small, and usually they're close to the fulcrum. They're up on the sail, and they're too close to the fulcrum point of the boat, center of gravity. So they have too little effect. So you're having to use the aft diving planes to do everything. Well, the problem with that is that when you surface or dive, you have to change the angle of the bow. You can't go down on an even keel. And that sometimes raises problems. And it's a technique. You learn it. It's like learning to drive a stick car, I guess, after having an automatic. It can be done. It's just it requires a little expertise. And for the beginner, it's not something I would recommend. So to have forward diving planes in the bow, forward of the fulcrum, work out really well. And here we have a boat that is small. It has an interesting naval history. It's in 1/32 scale, so you don't have to strain your eyes trying to build it. You're not like you're trying to look underneath a 10-power glass trying to build this thing. Tamiya makes a very nice gun kit for it, already available. Props are easy to find in that scale that happen to fit it. Everything that goes along with the boat is readily available. It's not difficult to find. Even the motors are cheap. The motors for like a model boat motors for like Type 7s or something of that nature usually are probably Dumas. They're the kind of the Pitman motors, but they're sold by Dumas model boat company. Those are $40 a piece motors. The little ones that go in a Type 2, I bought 2 of them today for $10. They're just little simple motors that are very nice, very easy, everything else. It's a lot less expensive. It's smaller, has great history. I can take it any place. It's got forward diving planes. It meets my idea of something that's easy to move around and should be easy to maintain and build. Now, I'll admit the Type 9 has got a lot of features on it that you just can't cram into a small little Type 2. But there's a lot to be said for being able to pick it up and put it on the overhead compartments, too. Anybody else?
I don't believe the minimum is 3 on some boat.
On an RC submarine, the minimum is about 5. When you count in your fail-safe and you count in, let's say you have torpedoes, that's about 5. However, I would recommend no less than 7. On my Type 9, I have 15 functions working on 7 channels. Okay, well, if there's no further questions, then this will conclude this end of the lecture, and Skip Acey should be next. If you have any questions, be sure you ask him.